So our first presentation will be about the carbon sequestration at national and European scale session, which was convened by Felix Seidel and Sonja Keel. And we will hear from Henrike, so go for it. And 3 minutes, please, Henrike.
Yeah, thank you. I had the pleasure to take part at the session A1, carbon sequestration at national and European scale. And first of all, I thought, well, how to summarize all that happened in that session? Well, it's a word cloud. And yeah, of course, you have carbon sequestration in the middle. Around there, you have different wordings, soil organic carbon, of course, carbon loss mitigation. I inserted stuff like missing, like lacking, because I somehow got the feeling that often it's different to really get good data. There's still a lot of knowledge missing. We're on a good track, but still somehow to model stuff and to be quite regional specific, there's still stuff missing. So yeah, just as a broad overview. My next slide mainly consists out of one statement by Lorenza to challenge the current result against experimental data and refine the estimations if necessary. I picked that because obviously modeling is a big part of the stuff we're doing, but still going to the field sites, sampling, putting value to long-term experiments, just gathering experimental data is quite necessary and will still be, always will be part of what we do as soil scientists. And my third slide, yeah, somehow it's like the communication issue. It was often raised. We all know that by talking about carbon sequestration, we have like a big miscommunication potential. And yeah, that was, well, it was mentioned by Johanna when talking about the emission factors. It was mentioned by Felix. It was also mentioned when talking about, or with policymakers, talking with farmers. So yeah, always mind the audience, mind your wording, and yeah, that's it for me.
Thank you, Henrike. We will have the presentations by group of themes. So we'll have the presentations one after another. Then after each group, you can give your input. So thank you, Henrike, for that already very creative interpretation and for setting the bar for the next colleagues. We will now hear about the carbon sequestration and trade-offs session, which was convened by Felipe Bastida, Miriam Gross-Schmulders, and Cristina Aponte, and we will hear from Ulises Ramon Esparza Robles from BOKU.
Thank you. Thanks for the nice introduction. So I now can skip the first slide. And I would like to summarize the whole session as a very nice way to bring different points of view. Oh, yes, thank you. That had really broad focus in different areas. So there was presentations from the Arctic down to the data from the down Mediterranean South, and also from mineral source to peatland. So there were these three main EGP projects presented, and also some nice presentations. And yeah, of course, I also thought about a summary of workload, and you might guess this contour of the Latvian country. And so this was a workload made human-based. So that was the topics that I found being the most mentioned in the session. And some of the remarks that I selected was the importance of peatlands, because they have a big influence in the climate, and they are crucial for the mitigation potential. They have a big potential if we manage them correctly. Also, the N2O emissions, which were the main topic in the trade-offs, apparently, and with the focus of cropland, they have when applying organic matter inputs, the potential to reduce the emissions when there is a replacement from mineral fertilization to organic, in the specific case of compost, and the risk of the increase them when there is an addition to the mineral fertilization. And the most mentioned concept during the sessions, this was machine work cloud made by what the speakers were saying, and we can see here the measurements were the most mentioned word. We also can see modeling Europe experimental sites practices, and as a way to summarize is that now most of the projects have identified a lot of knowledge gaps, and there is set up the way to progress in these trade-offs. And one of the main highlights was that the value of these field measurements, and especially long-term field trials. Thank you.
Thank you, Ulysses. That's really beautiful. And it's nice to see that young scientists as well as the senior researchers who get to hold the microphone up. So well on your way to with your presentation skills. Okay, we will hear about the carbon sequestration routes and amendment sessions convened by Rebecca Hood-Novotny and Isabelle Bertrand and Anna Wavre by Celia Fernandez-Balade from BOKU.
Thank you. So to start with another word cloud, I want to highlight the keywords that were mentioned in the oral presentation. So we were talking a lot about, of course, roots, root biomass, root carbon inputs, especially in winter wheat, and also on how to optimize these carbon inputs by genotype selection. So in the oral presentations, they were mainly results from the project MaxRoot, where there was a huge field experiment happening last year, where 10 different winter wheat varieties were tested, and also linked with other projects like Carbosec, where a root to shoot biomass database is created. Then I also want to highlight the keywords in the poster sessions, because some new words came into the game, like rhizodeposition, labeling, certainty. So this points out also the importance to not only determine root biomass carbon, but also rhizodeposited carbon. Now I want to briefly go about on to the highlights of each session, each talk in the session, starting with the yellow box. At the top, Axel told us about the importance that carbon saturation is not limiting carbon sequestration, so there is room to increase carbon inputs. Then Henrique was showing us that it's possible to increase these carbon inputs by increasing root biomass selecting genotypes, and this is very site specific. So in the same line, we also saw results from Agne and Fabian on winter wheat as well, where they looked at arbuscular mycorrhiza fungi colonization and also root architectural traits. They also saw the results vary between genotypes, but they are also very site specific. So this brings the importance of taking into account these pedoclimatic boundaries when talking about root management. Finally, Simon brought this new root to shoot ratio database, and he told us there were some challenges gathering this data regarding a lack of standardized methodologies that are not standardized regarding root sampling. For example, the depth considered, the sieve size when separating roots, and also the sampling time when taking these root samples. So to end with, I want to show this nice picture Henrique included in her presentation, because indeed roots are totally rooting for us. So we can't forget about this importance of below ground carbon inputs. And it's very exciting to see that these EJP projects are already starting to fill the gap in this regard. Thank you.
Thank you, Celia. It's really amazing to see all the beautiful slides you have created with so little time. I am missing Walter on stage. I don't know if he's not here. Oh, okay. Yeah, it's time for your presentation as well. So we are hearing about the closing carbon and nutrient cycles session, which was convened by Sabine Ho and Walter from Walter Rossi Servi from Wageningen.
Yes. Hi. Yeah, I'm not a soil scientist, so I cannot present specifically the results that were actually disclosed in the in the session that I was observing. I would like to thank Donata. She's a soil scientist from LUMS. She helps me a bit to understand what was discussed there. Yeah, in our session was to discuss the results from the EOM for soil and also basically an introduction of the biocash project. These projects basically address the benefits of external organic matter like digestates and composting and agriculture residues. 6 presentations were focused on the EOM for soil, showing the main findings. 4 presentations addressing really focus on the benefits of the biochar. I like to highlight this figure from a paper where they show in the upper bars a lot of benefits in different indicators of biochar. It's really impressive, and only few of them, sometimes perhaps marginal, for against biochar. I think was quite impressive. Yeah, and the one picture that one quote that strikes me that the potential is really utilized, mostly because the costs, production costs on thermochemical reactors are quite expensive. So it really hampers the scale up. And I'm from the Economic Institute. I think it would be nice to have some sort of a cross-sectoral interest should unlock incentives in different sectors, like now it's agriculture sector, but also bioenergy sector and also chemical sector should unlock incentives to facilitate investments in these thermochemical plants to enlarge the supply of biochar. Thank you.
Thank you. So we have a couple of minutes for input, questions, discussion. I imagine most of you were in at least one of these sessions. So what do you think? Did they make the right selection? I see people nodding. Does anyone have a comment?
Please, at least one question or remark. Nobody. Okay. No problem. Oh, yes. Okay.
I would just talk about biochar. I think we often pardon? To Walter, yeah. No, one of the remarks, I think you're very right with the trying to integrate biochar into wider systems. But one of the things we have to remember about biochar is a very sort of like new technology. And we have to remember things like solar technology 30 years ago was incredibly expensive, and everybody said it was incredibly expensive. And those economies of scale is what we require with biochar, and it's a substitution from I mean, there is still debate about incineration within the EU, and I think that's a good debate still to have. But whether we can substitute incineration with biochar production may be one of those things that we need to talk about.
Walter, that was not a question, but maybe you can react on this.
The larger demand for chemical products was mainly liquid fuels and electricity, and they usually treat biochar as a residue out of the production. And adding value to this residue can also drive the demand, given the large demand in the agriculture sector. So can also create some sort of force to actually unlock these investments and create a scale in that sector.
Thank you very much, Walter, Celia, Ulysses, and Enrique. Louise,
thank you. All right, so thank you so much. It's time for the Indicators and Ecosystem Services group. So I am asking Simon, Dylan, and Claire on stage. Another Claire this time. So we will start with the Indicators for Soil Ecosystem Services session, which was convened by Klaus Jaroche, Isabelle Poussin, and Stefano Mocali, and will be presented by Simon Seilbon from CRAE.
Yeah, so good morning, everyone. I'm Simon, and yesterday I made the wise choice of attending the B3 session, who's focusing on the indicators for soil ecosystem services. So here I won't focus on the results of the different presentations. Of course, they were very interesting, but with a high diversity of indicators studied, but I mainly found storyline in the conclusions of the presentations. So first of all, in most of the presentations or even in the discussions, the same challenges were put forward regarding the use or the evaluation of the indicators and in very heterogeneous context across Europe. So here is a list of the main challenges that were discussed. So we heard a lot about the spatial and temporal variability issue, the lack of harmonization of measurement and methods, measurement methods and protocols. There is a lot of there is a lack of reference threshold values, difficulties to upscale it, and there is also a lack of knowledge, obviously linked to soil functions or their properties. And then we also had discussions about the fast data acquisition. Another thing I wanted to highlight is this original research presented by Tatiana Rittel. That's that's here. I have no time to explain the context of the study, but the general objective here is to develop simple indicators for the farmers and advisors. And what I particularly liked was the approach used in it. So for each indicator, you calculate the ratio between the obtained indicator value and the maximum value you can get in the farm context. And here is the kind of result that have been presented. I personally liked this tool because it's very visual and the farmer or advisor can know, okay, that's the situation, that's the quality of my soil now, and from that, what decision could I make? Yeah, and then my last slide is also a cloud of words. So these are all the keywords of the abstracts, and I thank all the presenters, so the speakers of the yesterday's session. Thank you.
Thank you, Simon. Again, beautiful presentation. We're going straight to the Soil Biodiversity and Ecosystem Services session convened by Alessandra Trinchiere and Sébastien Fontaine. And I will give Dylan Warren from CLEA the floor.
Yeah, so, well, thank you very much and congratulations to the participants of the breakout session. That was, I mean, I found it very interesting and inspiring. So I'm Dylan Warren Ruff, I'm the reporter of this session. Something that became traditional in the last 5 minutes. Well, nothing actually very special. We talk a lot about soil. We talk a lot about microbial diversity. We talked a lot about agricultural practices that steer soil biodiversity in the context of ecosystem services. Now, something that actually steers my attention all the time is this data. We know a tiny bit of soil biodiversity, but something that emerged extremely clear in the session is that we are already able to appreciate a significant change. So this obviously let us understand that we have a huge potential to use this fauna, and a lot of in the session, a lot of time in the session was dedicated to how to use it. So I'm not going to summarize the whole session, but identify two kinds of ways to using it. Direct method, we apply them, simple, straightforward. A second method, which I found actually very, very interesting and inspiring, and Sébastien Fontaine called it, let's say, mimicking nature. So applying practices which are able to stimulate the biodiversity we need. We need this biodiversity to improve our systems, both from a productive and an environmental point of view. How does it work? Very simple. Whatever we do, we apply a filter. Whatever we do in the field, we actually apply a filter which steer our functional diversity, which at the end improve or mediate, let's say, the ecosystem services we are looking for. Bad news, we have been selecting microbes since agriculture was born. So we are dated back to 10,000 years ago. So there are many colleagues that are claiming we have been missing microbes. When we selected varieties, we obviously introduced different exudate into the soil, which obviously steered different soil biodiversity. So all of this to say that I left the session with this thought. So how we can exploit this potential that we really need, this potential of the soil biodiversity, without losing genes and organisms that can be critical for the challenges we are facing today and tomorrow. So with this, I thank you.
And thank you, Dylan. We are hearing about the scientific research outcomes towards the production and sharing of standardized and harmonized EU soil data, session which is convened by Maria Fontapié and colleagues from Work Package 6. And we will hear Claire Froger's thoughts from Inga. You have the floor.
Thank you. So hello, everyone. So I was in the C4 session about scientific research and the production and sharing of standardized and harmonized EU data. So as you can see, there is also a word cloud, but much smaller for you to see all the different words. So we talked about different monitoring networks. So a lot about how to choose the site, about the land use representativity. How can we see the changes, especially in associate stocks, using those monitoring programs, about the depth, about how to use data grid to select the sites, about the methods to select also where you can make the samples and the scale of the different monitoring programs. And we also talked about the difference between the national monitoring programs and also the European monitoring program, which is Lucas. Are there differences? And indeed, there are differences between the data sets, and also can we combine them? Can we combine them to make maps? And so this was more about the different monitoring network. We also talked about the data exchange, which is the big part. So we saw a lot of different data management from different countries to get all the different analysis, so biodiversity, but also soil chemicals and soil texture, process it, and to have it's available for different users, so farmers, but scientists and also policymakers. But there is a question about, those are mostly national databases that can be used for national programs. But what about the possibility to have other users from the world? So for that, we need a translator, because the data sets are in different formats, with different encoding and different description. So this is the objective of the GLOSSIS, the Global Soil Information System, to have the same format for all, and for those to be available for different users in the world. And to finish, I saw that in Flanders, there are already in the future, because you can virtually dig a bit from the database to see what is underneath your feet. So thank you for your attention.
Thank you. I invite you to have a seat. And people that were or were not in these sessions, is there any slides that stood out to you? Maybe one of the word clouds or something different? Or any questions?
Come on. Okay, I just was wondering, for the biofertilizers, was there any conclusion? Does it work? Simon.
There was any conclusion? That's the question on the biofertilizer. Well, not really. I mean, this is more this is more a thought that, came up to my mind. No, I mean, the research that were presented during the session, some of them address the use of biofertilizers, and while there is this other middle. So I found it interesting, these two ways of looking at the same picture. So yeah, unfortunately, we don't have an answer yet.
Thank you, Dylan. Can anyone else comment? Maybe the original presenter who presented these?
It was online.
Oh, it was online.
Then,
Okay.
then no.
No further questions or remarks or additional information? Thank you very much, Simon.
Julie says you had a
Oh.
you had a question?
Where?
Yeah.
Oh, wait. Ulysses. Difficult question.
Yeah, are you aware how these virtual digging pits works? Because I think it's the best way how to make people aware of soil. It's usually difficult to see it. It's difficult to we always step on it, right? There's a lot of people who, when we say we study soil, they say, "What? Sorry." So I think that's a wonderful initiative to show people what is soil about.
Claire.
Yeah, I think maybe someone from Flanders, I see Driesland the back, can answer, but he showed that in the interface, you can select a point in Flanders, and you have all the information about the soil you could have at those precise points. But that should be a project, actually, to have a virtual view of soils.
Yeah. It's a flattering image that Claire made. Yeah, so it's not really. Yeah, it's maybe virtual reality upon the letter. It's just a tool you can get do a virtual drilling on your smartphone app and get some results from our database of what we know about the soil below your feet. Can be used by anybody as long as you are in Flanders.
Okay, thank you. If there's no more questions,
No.
Thank you.
Thank you very much.
Big applause. Thank you. Yes. And we will move on to the Soil Management and Innovations group. So Javier, Diego, and Catarina, I invite you on stage. We'll start with the using participatory design for developing farmer-friendly tools for soil practice and schemes session. That was a long title. It was convened by Sabrina Assin and Marlene Hanegraaf, and we will hear about it from Javier Renovel from CICIC.
Well, thank you for the introduction. I decided to combine some of the concepts that you mentioned into 2 slides. They're a bit longer. And well, first I made my own version of a word cloud. Very original. And I realized after watching all of the presentations and talking with the presenters that there wasn't a single keyword that could define or summarize the whole session. So I selected several keywords, the ones that are highlighted in bold, that I think when integrated, give a pretty good summary of the session. And starting by co-creation. Which was mentioned a lot, and it was very important when analyzing the relationship between scientists, farmers, and other stakeholders, mainly to be transparent, aim for simplicity and comprehensiveness. Because this way we can find a common language, a common vocabulary among stakeholders. Which can be combined with then the engagement. And well, this is very important. It's important to engage all the stakeholders to be able to hear other perspectives and then be able to interact accordingly. Well, after the engagement, I also consider very important innovation, which there were two parts of. The methodological one, the more technological one, that this is one I consider as methodological. But also the participatory policy one. And finally, there was the dialogue. And we consider it was very important to be efficient with our dialogue and to have some focused efforts so that with the little time that we might have to communicate with some of these farmers or some of these people, to try to address it so that this communication will lead to as many soil changes as possible in the biggest amount of land. And of course, it was very important to, at the end, bridge all of these concepts together, which Amanda did very well by explaining the importance of linking this knowledge with the impact that we want to create. And in my second slide, I try to visually represent what I did in the previous slide. So, well, we start with a fuss, a mess. This is all of the variables, all of the scientific knowledge, all of the different definitions. We saw this in the first day of this event. That, well, definitions are quite a big problem. So we should aim to simplify them. Once we get to simplify them, we combine it with the innovations that I mentioned before, and then the stakeholder dialogue, the involvement, etc. Then we can create a toolbox. And this has to be a friendly toolbox so that all farmers and stakeholders can use it, so it can be simple for them to understand. And once we have this, it can lead to great results, such as having great soil health, productivity, and of course, happy farmers. Thank you.
Thank you for these innovative slides yet again. I saw multiple people taking picture of your beautiful visualization, so congratulations. We will continue with the innovation and methods for data acquisition sessions, which was convened by Emmanuel Vaudour and Johanna Wetterlind, and we will hear from Diego Urbina Salazar from INRAE.
Thank you. Good morning, everyone. So it's quite difficult to keep the level because I am not so creative with my slides, but I hope I can transmit some idea for you. Okay, thank you. So, okay, this is already for the presentation. And I just would like to start that say that in our section, it was a really multicultural section. We had people from several countries. I'm so sorry if the flag of your country is not in my slide. Don't hate me for that. But it was really nice, the discussion during all the section. And I would like to start with this simple image that represent the large quantity of soil data that nowadays we can have in some place, and is usually represented by what you can imagine, the laboratory analysis, for example, remote sensing data that the main focus of our section, it was remote sensing techniques to soil prediction attributes, and some coverage that are used to predict soil attributes in order to, for instance, elaborate high-resolution maps for the decision making. So the second slide is I take some image from Emmanuel, the cloud words, and it's very interesting because this is represent the cloud words in the last 5 years in terms of soil organic carbon prediction using satellite data, that the main studies were carried out over Louis soils and Canby soils. So this is represent the importance that more studies are necessary to keep to going further and use more remote sensing data, but not just considering soil types, but also different disturbing factors related with the soil surface condition, such as soil moisture and soil roughness, and some agricultural practices as cover crops in annual and perennial croplands, and of course the selection of the sensors or the instruments that are related according to the target that you have to predict any soil attribute. So the last slide, I would like to start saying that during this section we discussed about the soil variability from one region to another region. So one question that I would like to, I proposed during this section, it was how to use different soil data, or this is kind of big data, in order to improve data acquisition methods, prediction models. So I just take some idea from Fanny presentation that it was so nice. And as an answer, we can to answer this. One way to respond to this question is looking at the importance between the synergy between the remote sensing projects, EGP projects, such as Steropes, SenseRes, or Profile, that contribute to generate different interested information in order to provide for us baselines and line directions to know what and where and during which period use the different soil data in order to quantify soil attributes using remote sensing data. So yes, this is all. Thank you.
Thank you, Diego. Very interesting. We have already come to our last presentation about the breakout sessions, about the sustainable soil management session, which was convened by Lisbeth Johansson, Lorena Chagas-Torres, and Lorenz Ndama. And we will hear Katarina Morelset from SLU. Thank you, Katarina.
Thanks a lot. Oh, that was wrong. Exactly, yeah. So last presentation, I will be fast, also since I've not been as creative as basically all of the previous speakers. So in the sustainable soil management sessions, it was these three projects who organized it, Scale, Soil Impact, and SoilX. And one of the main messages from both the project updates, but also from the other presentations of that study was that soil structure matters. I'm working on soil structure modeling. This message made me incredibly happy. Actually, almost as happy as still being considered a young scientist. So, and when we think about soil structure, then I mean soil hydraulic properties are important. And if we speak about soil hydraulic properties, we speak about water, which is important. And the topics addressed during the session were erosion, then also and agriculture under extreme weather conditions, as well as soil compaction. So, and I was told before that it was fine to kind of cherry pick from the presentations, which I did. Apologies for that. But there was one presentation from Martin in which he actually reminded us of the fact that even though we talk a lot about carbon, and carbon has been identified as one of the most important parameters when we had this initial questionnaire. You all remember the questionnaires in the first year. But what we often forget is this part here, the water storage capacity and nutrient retention, which is also very, very important. It has been important, it has been considered important by many countries. There was another presentation by Lena on soil compaction, and she modeled the soil compaction risk in Switzerland. And what was interesting here was that, I mean, the distribution of the annual presentation was kind of a predictor of the compaction risk. So soil moisture and water availability is a thing here. We know that erosion and compaction maps are needed for stakeholders. In that session, there was quite some modeling on the regional scale, because this can help guiding sustainable soil management. Then we know that whatever we talk about in soil, soil is dynamic, it's highly dynamic. So we actually need models in order to create these maps and in order to make predictions. And here resolution and scale matter. So, and we saw, for example, a map of Flanders, erosion risk map. And depending on what resolution was chosen before running the model, there were basically different results, and Flanders looked pretty different. I was too late in taking a picture of that. Apologies for that. But screen through the abstracts and the presenters, and I guess you will get that picture. Yes, and validation is key. In contrast to Tim, who works on the global scale, we actually have the luck or bad luck that we actually can do that and should do that when we are modeling. Thanks.
Thank you, Katarina. Please, yes, and please have a seat with your colleagues. Maybe a question for the audience. I heard Diego mention that in his session there was some discussion going on. Can someone add to this, or were any of the other sessions, did any interesting discussions happen that you would like to elaborate on? Maybe the conveners can contribute. Don't know where they are. Question over here.
Yeah, thanks for these three summaries, which were excellent. And I want to come back to you, Kata, and thanks for mentioning soil hydraulic properties as very important. And I just want to comment that I had a very interesting talk to the head of the soil taxation system in Austria. And due to climate change, they have changed the taxation system so that formerly the soils with the highest organic matter content were the most valuable. Now the soils with the highest soil water holding capacity are the most valuable because they are more resistant and resilient towards climate change and drought. Yeah.
No further questions. Everybody's satisfied. So thank you, Javier, Diego, and Katarina. And
yes, I want to thank all of these young scientists again for all of the creativity you've put into this and all the work into not only getting this ready in less than a day with an evening of dancing in between, but making it all very interesting, concise, and visual. And I think you'll all be fine going forward, presenting in front of important people.